Hello, my friends. It's the NOLA Mathman joining you for another math adventure. I don't have my usual gear. As you can see, I'm in my summer New Orleans wear, but I'm still representing NOLA. So, unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to solve problems involving statistics and parameters. The concept we're looking at is statistics and probability. The skill we're looking at in this section is statistics and parameters. So with no further ado, let's get into our lesson. So in this first example, we're identifying the sample and population for each situation. Then we're going to describe the sample statistic and the population parameter. Again, all these items are found in your textbook. You want to define them and have understanding what each of these mean. So in this problem, the sample is the group of 10 patrons that are going to the restaurant on Saturday. And the NOLA Mathman writes this as a group of 10 patrons on Saturday night. The population is all the patrons in the restaurant on Saturday night. I would assume. All the patrons, let's see what the NOLA Mathman writes here. All the patrons of the restaurant. I would assume all the patrons on Saturday night, since you're picking from that. But no, it says all the patrons of the restaurant, so it could be all the patrons, could be possible sample. That's what they're saying. The sample statistic here is going to be, what does that mean? Well, what we're looking at in this problem for that particular sample. So in this problem, we're looking at the mean amount spent on beverages for the sample group, which is the group of 10 patrons that are randomly selected. That would be our sample statistic. So the mean amount spent on beverages for that sample group, which I just communicated a few seconds ago what that group is. Now, the population parameter is the mean amount spent on beverages for anyone who attends that restaurant, I would assume. If we kind of look at, the sample statistic models the sample, the population parameter models what you wrote for population. That's the thing you want to use. So the population parameter is the mean amount spent on beverages for all people who attend the restaurant, for all patrons. So that is what we're writing here. And so that's our first example. Let's try it again with another example. So a produce clerk randomly selects 20 bags of apples from a shipment and counts the total number of apples in each bag. The mean number of apples is calculated for the sample. So again, the sample here is the randomly selected 20 bags of apples, because that is what you're studying and observing and analyzing. The population, what will that be? What do you think that is? See what the NOLA Mathman comes up with. It is all the bags of apples from the shipment, I would assume. Let's see. All the bags of apples from the shipment. That's what it looks like the NOLA Mathman is writing. So yeah, great minds think alike, so that's the answer. The sample statistic is the mean number of apples for that sample size of 20 bags of apples. That's what I would assume that will be. Let's see what the NOLA Mathman comes up with. The mean number of apples which is basically the 20 bags of apples randomly selected. The population statistic is the mean number of apples from all the bags of apples in the shipment. So let's see what NOLA Mathman writes here. Mean number of apples of all the apples. So it's a mean number of all the apples from the shipment. And that's about what I said. The NOLA Mathman worded a little different, but it's the same point. So now we're doing a different problem. Find and interpret the mean absolute deviation. So we get to learn a new type of statistic term here. And we have different steps of finding it. So the problem we're doing is a fisherman records the weight of each black bass he catches, and these are the 6 weights. So we want to find the mean absolute deviation of these 6 weights that he has. So first thing we have to do is calculate the mean. Another word for mean is average, and you simply add the 6 samples or illustrations and divide by the total number of samples that he had, which is 6, and that gave you an average of 10. That's the average weight of the 6 samples. So after you do the mean, the next step is you must find the absolute values of the differences between each sample and the mean. So that's what we're going to do. The absolute value of the differences between each sample and the mean. So for instance, the first sample is 12, so we call that x1, and we will get the absolute value of the mean, which is the average minus the sample 1, and so it'll be the absolute value 10 minus 12, which is the absolute value -2, which is equal to 2. So that first absolute value is going to be equal to 2 for the first sample. So now you do the second sample, which is 7, and you calculate that same equation, mean minus the particular sample. So that will be in this problem 10 minus 7, the absolute value of that. The absolute value of 10 minus 7, the absolute value 3, which is equal to 3. So the second absolute value difference between the mean and the second sample is 3. And so we will do that for each of the 6 samples. And so that's what the NOLA Mathman is writing here. The third example will be the absolute value 10 minus 8, which is the absolute value 2, which is 2. So now we need more room. So now we move some stuff out the way, and we're going to do sample 4, absolute value of those differences. And that will be the absolute value of 10 minus 13, which is the absolute value of -3, which is equal to 3. And so now we're going to do the 5th sample, comparing that to the mean, and that one is 6. So we have the absolute value of 10 minus 6, which equals the absolute value of 4, which is going to equal 4, which again the NOLA Mathman is calculating here. And then we'll do the last sample, which is equal to 14. And we will take the absolute value of those differences, which is 10 minus 14, absolute value of that. And since 10 minus 14 is -4, we will take the absolute value of -4, which is equal to 4. And so we now have the absolute value of all the differences. So that leads to step 3. And step 3 is we're going to find the sum of those differences that we just calculated. So we're going to add all those together, which was 2 plus 3 plus 2 plus 3 plus 4 plus 4. And when you add all that together, we get a sum of 18. That's step 3. Step 4, again, what I'm writing is the mean, because we will need that we've already calculated. I'm putting that off to the side. So step 4 is we're going to find the mean absolute deviation at this point. I believe that's what we're going to do. See what the NOLA Mathman does. So how do you get the mean absolute deviation from these differences and the average of the 6 samples? Well, how do we do that? Well, we're going to learn this definition. Mean deviation, let me say it again, tongue twister. Mean absolute deviation will be known as MAD. That is equal to the sum over the number of samples, which is 6. And so the mean absolute deviation for this example is equal to 3. And so we want to interpret that answer. And so the NOLA Mathman says, on average, the weight of each black bass is 3 units from the mean of 10. And so that's how you summarize. So that's how we do it. So now we're going to do another example, and we're going to do these same steps to a different problem. So which problem are we going to do? It says here, find the mean. That's what we did in the first step. So we're following the same process we did in the last example. Which one are we doing? We're doing number 8. Yeah, it's circled. There we go. We were wondering which one we're going to do. So we're going to find the mean of those 5 values. So we add each of them up and divide by the total number of terms, which is 5. And that will give us the average. So when we do that, the average is equal to 24. So we call that X, little line above it. I forgot what those called, but yes. So that's how you classify. That's another way of writing symbolically the mean. So now we're going to do what we did in the last problem in step 2, is find the square of the differences of each sample or each term. So we take the average and we subtract each particular term. So we start with the first term, which is 23, and we have to find the square of the differences. So that's what we're going to do. It's a little different this time. We're finding the square. We're doing the square of the differences, not just the difference. So that's a little different. So we will take 24 minus 23 and we square it. That will be 1 squared, and that will give us 1. Second one, we will take 24 minus 18. Again, the mean will always be subtracting the term, and we're going to square that, and that will give us 36. And then for the third, we will take 24, and we will subtract 28, and we will square that, and that will be negative 4 squared, which is going to equal 16. And then for the fourth term, 36, we have 24 minus 36 squared. 24 minus 36 is what? You're right, it's negative 12. Negative 12 squared is 144. And then last, we have the fifth, and that will be 15 minus 20, 24 minus 15, I'm sorry, the means first. That will equal 9 squared, which is equal to 81. So at this point, we want to write out our differences, the square of the differences, the sum of the squares of the differences. And so in step 3, we want to find that sum. So we're going to add those up. And that will get us a total of 278. So in step 4, we have to find the standard deviation. Oh no, we're going to do different. We're going to find the variance. Okay, so we'll do something a little different. We're going to find the variance. So here, that is what we call, that little symbol I forgot what it's called, it might be theta, but it's a little reverse P, sideways P, I would say. And so to get that, you take the sum, divide by the number of terms, and you get 55.6. Now you're going to find the standard deviation, and the standard deviation is the basically sideways P term. That's the symbol for it. So in order to make that that little figure squared, that you take the square root of what we just did, which was 55.6, and that will give us the standard deviation, which is in this case 7.46. And so we have to interpret that answer like we did in the last example. And so we write down our mean value, which is 24. The standard deviation is 7.46 in relation to the mean. So it's a good bit away from it. And so the way we would interpret it is, with a mean of 24, the standard deviation of 7.46 suggests, we're interpreting it now, so the NOLA Mathman says it suggests that there is a good amount of deviation from the data. There's a good bit of distance between each thing and the mean. So there is a good bit of deviation, and the NOLA Mathman concludes this is due to the outlier 36, which is one of the values that is far away from the mean of 24. So we've gotten some experience in statistics, and so we've enjoyed our immersion into statistics for the first time. And so until we do another math adventure, this is the NOLA Mathman signing off. Have a blessed day.